Okay, welcome everybody. As mentioned, my name's Sam Ritchie. I'm from Codesplice in Perth. This is Ben Teese, not Bill. He's from Shine in Melbourne. And we're here today to talk to you about alternatives to MVC for native mobile development. So the background to this talk, if you heard this morning, was that both Ben and I presented separate talks at YOW Connected this year. So YOW Connected is the mobile conference down in Melbourne. And the YOW organisers got in touch and said, hey, do you guys want to do a joint presentation on the main YOW tour? So, of course, we said yes, that'll be awesome. The problem is that Ben's talk was on React Native, which is a JavaScript-based view framework, and my talk was on ReactiveCocoa, which is a Swift FRP library. They're not really the same thing, although they do both start with the word React, so they must be practically identical. Our names, our Twitter names are up here, so if you are live tweeting this, please get the names right, otherwise we won't give you any love hearts. So, what we're going to go through today is I'm going to talk about some of the issues that we've got facing mobile development. There's some unique issues that and challenges we need to resolve. And then Ben's going to introduce React Native and talk about how they can solve some of those problems. I'm going to do a similar thing with ReactiveCocoa, coming from a slightly different direction, but incorporating some of those React techniques to try and solve the same problem. And then Ben will introduce a couple of other technologies that you can use to try and take those concepts a little bit further. So, this talk isn't a pure technology demo. Okay, we are using React Native and ReactiveCocoa to sort of illustrate some of these concepts around state and around immutability and view rendering and those sorts of things, but they're not just tech demos on those, and it's also not a hardcore functional talk. I've heard all these stories about Brisbane being this functional programming mecca, so I'm sorry there's no monad transformers or anything here. Or maybe there is, I don't know what they look like. They're somewhat like burritos, aren't they? See, there's a functional programming joke. All right, so let's talk about mobile development. Firstly, I'm a bit of a fan of the visual puns, so feel free to groan when they pop up on screen. So mobile development is hard, and it's not just because you might fall off the scooter. If you're a server-side developer, your job's really easy. Okay, a request comes in, you run some code, maybe update a database with send out a response. Okay, piece of cake. I'm just making enemies all over the place here. The worst that can happen is the request that comes in maybe doesn't, state-wise, the worst that can happen, the request that comes in maybe doesn't make sense in the context of the state you've got in the database, at which point you throw out a bad request to make it somebody else's problem. In contrast, with mobile development, we've got a bunch of things going on at the same time. So we've got a long-running process, and then we've got all of these callbacks happening asynchronously. We've got a UI touch events. We might have a network request callback. We might enter or leave a geofence. You might get a phone call in the middle of using your app. And your app needs to handle all of those and function reliably and predictably in all of those cases. Now, the problem with those isn't necessarily that we're getting asynchronous callbacks. The problem is that in a lot of them, we're mutating shared mutable state. Okay, and this is bad because it makes I hope you're all generally on board with the concept of mutable state. It makes your program unpredictable. Okay, you're not able to accurately or reliably predict how your app's going to behave inside a certain callback because you don't know how the state's been set up previously. And this is one of the reasons why Josh Abernathy, one of the guys behind ReactiveCocoa, came up with this awesome quote: UI is a big, messy, mutable, stateful bags of sadness. So one of the things we're trying to do is trying to introduce this concept of managing the state a little bit better and being a little bit more predictable and deterministic in how we render our views. Okay, and ultimately we're trying to make this problem of rendering views a little bit more tractable. Okay, I'll hand over to Ben, and he's going to talk about React Native.
Thanks, Sam. All right, let's just get that off the screen. All right, okay. React Native. Okay, so what I'm going to argue in this section of the talk is basically that React Native, and specifically the React programming model, is a bit of a gateway drug for starting to introduce some functional programming techniques to building user interfaces. Just a couple of details we'll get out of the way first. So React Native, it's a framework for building mobile applications, and it's targeting both iOS and Android. Okay, and whilst it's not really specifically aiming to be a cross-platform framework, it's aspiring to what they call a learn once, write anywhere approach. It's also using JavaScript, as Sam mentioned before. And whilst it uses some kind of web-inspired techniques for styling and layout and stuff like that, I think a really important thing to remember about React Native is that it's all native under the hood. So there's no HTML being rendered, there's no UI web view or anything like that, it's all native. If you've heard of the React web framework, React Native is really, it's essentially using the same model under the hood. But there is one thing I want to get out of the way now. I saw this was tweeted a couple of months ago, and as a web developer, I found it funny, basically because it's true. You know, let's not lie to ourselves here. And I certainly can't guarantee that React is going to be the last JavaScript web framework. In fact, I know it's not going to be the last one, but I do think it's the first in a long time that's introduced some genuinely new ideas to UI development. And that's kind of what I'm going to talk about here. And these ideas are kind of drawing upon programming research from the last 40 years, you know, since MVC was originated. And also they just leverage the fact that computers are a lot faster than they were 40 years ago. Okay, so what is this model that I speak about? So React is really just a reference implementation of some ideas, the original React web framework. And React Native just be thought of as an alternate representation of these ideas. So I'm going to go through some of these concepts now, and we'll put them under the general category of the React programming model. I'm going to start by introducing this concept of virtual view hierarchies, sort of lightweight in-memory representations of a view that you manipulate rather than actually what your device is displaying. And then I'm going to show how that leads us to be able to think about our UIs declaratively, to be able to describe them in terms of, you know, what they do at a point in time rather than how you go about manipulating them. And even to start thinking them as being sort of a deterministic output of a function that will always behave the same way given a particular set of inputs. And then finally, I'm going to talk about how we can start to model change within our applications really as this one-way data flow process, which puts it in a little bit of a point of difference to maybe what we've done traditionally with MVC, where you can have big cascading chains of events that are hard to reason about, or even if you're using two-way bindings, quite inexplicable behaviour, frankly. So let's get started with virtual view hierarchies. So if you know anything about React, you may have heard that it had this concept of the virtual DOM. So in the beginning, there was the browser DOM, and if we wanted to manipulate what the browser displayed, then we would manipulate the browser DOM. That, in the case of browsers at least, proved to be a little slow, so React introduced this idea of a virtual DOM. And so if we wanted to manipulate what the browser displayed, we would make changes to the virtual DOM, and then we would leave it up to React to form a diff between the two, and then to patch the browser DOM accordingly and efficiently. So in React Native, we pretty much have exactly the same concepts. You see, now we have this virtual view hierarchy instead. So React Native introduces the concept of a virtual view hierarchy. If we want to make changes to what's being displayed by our native app, we make changes to the virtual view hierarchy, and then we leave it up to React Native to assemble a diff between the two and patch the native view hierarchy accordingly. So the good thing about us starting to represent our view hierarchy using a lightweight in-memory object model is that we can actually throw that object model away with alarming regularity and recreate it from scratch without really having to worry about the implications of that anymore. There's no more poking into a native view hierarchy manipulating. We can just throw the whole virtual view hierarchy away and then let React take care of rendering it efficiently for us to the native view hierarchy. And this brings us to declarative UIs, this idea that we can now start to describe our user interface declaratively. And so to do this, I'm going to give you a little example. So this is an app I wrote. It's my things not to do app. So as you may know, in JavaScript land, whenever a new web framework comes out, which is, you know, let's be honest, pretty much every week, it's customary to write a to-do app. So I've just turned it on its head a little bit. Here's a React Native application that I've written that is my list of things not to do. And we'll just take it for a little spin now. Here we go. So it's got a list of items, just like any other. This is all native. Top of the list, not to do have children less than 18 months apart. I've done that before. It was terrible. I highly recommend against it. And I'm going to make it that I can filter this list down just here at the top. So how might we go about implementing something like this with React Native? Let's start with this top level component for this page. So we'll call it TD main. Everything you see prefixed with TD is a component that I've written myself, and it comprises the filter area at the top and the list and then the button down at the bottom. here's some code for this component. Now React Native uses ES6 modules, so we're going to bring in the React Native module here at the top and then bring in a couple of modules that I've written myself. I'm going to extract a couple of classes out of the React Native module. Let's just say for now we're going to hard code the data in, although I'll loop back on this a little later on. So here's the code for the actual component. It's a class that extends upon a base, and it has a render method. This is a really important method because it returns a representation of this component at any particular point in time. And clearly that is not JavaScript. What is this, you might be asking? Well, this is JSX. The important thing to remember about JSX in React or React Native is that A, it's entirely optional, and B, at the end of the day, it all compiles down to JavaScript. And I actually think it's kind of instructive to look at what this JavaScript is. So if we were to take this JSX with a little bit of markup inside of it, this is what the generated JavaScript looks like. In our JSX, we've got our view tag up at the top here, so we just have some JavaScript generated that creates an element, a view element. We have our TD filterable list tag here, so we have some JavaScript that creates a TD filterable list element. We have a TD button, so some JavaScript is generated that creates our TD button element. We can actually pass properties to tags, and really those are just a hash that is passed to each element when it's created. And finally, sometimes we do want to actually access some variables in the surrounding scope inside our JSX. So we can do that using this little curly bracket notation. So all I'm doing here is accessing the global items list that I've set up. It can be any expression, any JavaScript expression I want, and that's just going to pass it in there when the element gets created. Okay, so let's drill into this user interface a little bit further. Let's actually look at the filterable list. This is the filter up the top and the list in the middle. What does the code for this look like? Okay, we've got our top level view tag. Really, this is just a container for other elements. It's going to have a text input at the top. That's where we're going to put the filter text in. And then we've got our list view. This is just something that React Native uses for displaying a list of data. It's got two properties. The first one is a data source. I don't want you to worry too much about the details of this other than to say it's just a mediator between a list and a collection of items. In this case, the important part is that the collection of items is this.props.item. Now, items. Now, this.props is a special property that each component can have, and this is how we get access to the properties that have been passed into the component when it's instantiated. And the really key part of it is, in the context of the React programming model, is that it's read-only. You don't really mutate what's been passed into you via this.props. And then secondly, we're going to pass in another property to our list view. Properties can actually also be functions. So in this case, we're actually going to pass in a function that gets given some row data and then produces some markup for each row on the list. Okay, so now we've got our declarative UI set up. We can think about the render process as follows. We have TD main at the top, render gets called, TD filterable list gets called and has the list of items passed into it as properties. It in turn sets up the text input. Then we have the list view, it gets a data source passed into it as a property. And then each of the children gets rendered in turn. This is kind of the render process, and I think it's really important to understand with React. Now let's talk a little bit about one-way data flow. So I've showed you a static UI so far. How do we actually start to model change with this? Okay, so if you remember, we've got this filter up the top. Let's use this as an example. Entering a string in here. How do we filter this list down and change what actually gets displayed by React Native? Okay, now it's time for us to introduce some mutable state. Okay, the good thing about the React programming model is it encourages you to keep mutable state as absolutely small as possible and to only put it as higher in the view hierarchy as it needs to be, no higher and no lower. So what we're going to do in this case is on the TD filterable list, we're going to add a constructor to it, and that sets up a this.state variable. And we're just going to assign it to be an object that's just got an empty filter string associated with it. So this.state is another special React component property, and this describes the mutable state for the component, but we try and keep it as small as possible. And on our text input, we're going to detect the event when text changes, and we're going to call this.state. It's a special method that each React component has, and what it does is it updates the state, but it also marks the component as dirty and in need of being re-rendered. Finally, we're going to actually filter our list down. So at the top of our render method, we're going to take our list of items that was passed in and apply a filter operator to it, just using a substring match as a criteria. And then we're going to pass the filtered list of items into the list view. Now, a really important thing to note about this is that we're filtering the items at the top of the render method. We're not filtering them somewhere else and then storing them as additional state, because then that's more state that people can mess with later on. We're going to recompute this every time that render gets called. Now, is that expensive? And do a lot of objects get created? Well, yes, but does it matter? Well, usually no. Okay. And the good thing about this is that we can start to think of our render method as being something that produces the same set of outputs given a particular set of inputs, this time in the form of some properties and a minimal state. So this code will get executed every time we enter a character into this field. And React takes care of making sure that this rendering process is efficient. So if we think about or visualize this again in terms of the way that change is happening, we have our onChange method, onChange event coming to our text input. It calls setState on its parent. The parent is now marked as dirty and in need of being re-rendered again. It renders its text input, it passes in the list view, this time with the recomputed list of now filtered items. It's only got one item in it now, and then that child gets rendered in turn. This is the process of one-way data flow in React. We propagated an event up to the highest point in the component hierarchy where that minimal set of state is called. The state gets mutated and then the entire subtree gets rendered again. This is one-way data flow. And it's such an important concept that I'm going to give you one more example. This time actually loading some data. So we've had some hard-coded data loaded in there. How are we going to load some real data? How does that process work? Now I'm going to introduce some state to TD main at the very top. Again, this state will be minimal, but it does need to be the list of items. We're going to make them empty by default now. And in the render method, we'll render these items from the state object. Now I'm going to use a hook that React gives me called component.now. This will get called when the component is instantiated first time, but not every time it's rendered, just when it's instantiated for the first time. I'm going to use a fetch API to just make a call to a backend. You don't have to worry too much about the details of this, other than to say that a couple of asynchronous operations occur, and at the end of it, we call setState again. And now it will populate this list of items for us accordingly and mark the component as dirty. And in need of now being re-rendered. So if we were to visualize this again using our virtual view hierarchy, now we've got an empty list, so by default nothing gets rendered. A call to go out and fetch takes place. Eventually it comes back in again, now with a set of results. setState gets called, and the entire view hierarchy now is marked as dirty. And we go through this rendering process again. We call TD filterable list, and this time we pass into it the list of items. It creates a text input, creates a list view, passes in the data source, and then creates each child in turn. And React Native takes care of rendering all of that for us efficiently. So this is the React programming model in a nutshell. And I believe a bit of a gateway drug to doing using functional programming techniques in user interface programming, because it lets you start to minimize mutable state as much as possible and have a very clear picture about the way change is flowing through your application. So if we were to recap on it, we had virtual view hierarchies at the start, lightweight in-memory representations of our view. We still had that enabled declarative UIs, and to be able to think about our view as being a function that takes an input and always produces the same output. And finally, this notion of modeling change with one-way data flow. This is the React programming model. And I think as a web developer, I've used Backbone and Angular and things like that, and they're terrific, but I think that the React programming model is great because they're very explicit about the way that you model data flow through your application, and I found that to be really handy. So we're going to change gears a little bit now, and Sam's going to talk a bit about ReactiveCocoa, and I think he's going to start that by posing what he believes, at least, is an important question.
Okay, so thanks for that, Ben. A lot of really, really good ideas in React Native, but what if, like me, there are other things that you would prefer to be doing rather than writing JavaScript? So I'm going to talk about how to use some of these concepts using a real programming language. Sorry, just quickly, are there any actual Swift developers in the room? Because when I did this down in Melbourne, I think everybody was a JavaScript developer. Not many, all right. So you guys are going to hate me. All right, so first I'm going to talk about ReactiveCocoa and how awesome it is. Then some of the issues that we run into when we're stitching ReactiveCocoa together with UIKit, which is an imperative object-oriented view hierarchy. And then how we can incorporate some React techniques to try and make working with this a little bit better. Okay, so first we're going to diverge from discussing UIs a little bit and start talking about, nobody got that one, did they? It's not as funny when I have to explain it. So I'm going to talk about functional reactive programming. So the way I like to describe functional reactive programming is it's just a shared library of reusable functions that allow you to deal with streams of events. Okay, so you would not write your own array sorting function. Okay, you would steal one. You would download it from GitHub and use it because it would be better than anything you'd write yourself. Similarly, you shouldn't be writing your own code to filter events and aggregate and throttle events. You should be using a library that does that, and that's what FRP libraries do for you. So in iOS, we've got ReactiveCocoa. ReactiveCocoa has been around for a little while. It's one of the more popular ones. It was originally Objective-C. Then when Swift came out, they rewrote it in Swift. Then when Swift 2 came out, they rewrote it again in Swift 2. And I bet they're stoked about Swift 3 coming out next year. So I'm just going to give you a very, very brief introduction to ReactiveCocoa so we can go on and have a look at the rest of the demo. So the core abstraction in ReactiveCocoa is a signal. Okay, a signal is a stream of events. In some RX libraries, it's called an observable. Okay, and within the ReactiveCocoa, within the RX community, events are usually represented as marbles, and that's what those round things with the epic frame rate are meant to be. So I'm just going to show you some of the functions that ReactiveCocoa provides out of the box to give you a little bit of a feel for how it works. Okay, so we can filter events by just supplying a predicate the same way we'd be able to filter an array. This is Swift code, by the way, so you know, if you're blinded by its awesomeness, that's why. We can apply an arbitrary delay to a stream of events. We can deduplicate events by skipping repeated values. This is very, very useful, as we'll see later. We can throttle events to avoid flooding a server because our boss is too cheap to pay for a good one. We can flatten multiple signals into a single stream of events if the signals are of the same type. We can use a signal as a trigger to sample events on another signal. Okay? Often this will be a timer, but you can also use it for things like button pushes and those sorts of things. And we can do a combine latest. Now what combine latest does is it sends a tuple of the latest value on each of the source signals. Now this starts getting very, very interesting because suddenly once you can access the most recent value on a signal, you can start sort of rethinking what it means to store state within your app. Okay, so now I'm going to introduce a demo app. It's not as cool as Ben, sorry. I've re-implemented the iBooks storefront interface, but I'm using comic books because comic books are really cool, according to 15-year-old me. And so what this is doing is downloading the top 20 comics from our server. It's downloading prices from the App Store for in-app purchase, and I've got to download thumbnails, of course, to display as well. Once I hit the bottom of the table view, then I reload the next 20, and we go from there. Okay, so how might this look in traditional MVC code before we start going reactive? So we'll probably have some mutable state. Again, shield your eyes if you don't want to be blinded by the Swift awesomeness. We'll probably have some mutable state at the top of our view controller. That's how it tends to be done. Okay, then within our initialization code, we're going to kick off an asynchronous call. Okay, and within that callback, we're going to mutate our state, reload the table view, and then we'll kick off another asynchronous call to get the prices from the App Store. Our App Store prices load basically when that completes. Again, we're going to mutate our state and reload the table. And then we've got a load thumbnail, which we call from our table rendering code. Again, predictably, within that callback, we mutate our state again, and we reload the table again. In the table rendering code, if you haven't worked with table views on iOS before, they are a callback-based API, so the view controller will ask, the table view will ask the view controller, give me the cell at this particular row. So what we do is we create a cell, then we access our local mutable state, our comic list, and we build our labels together there. We do the same thing for the price, but we need to be reasonably careful because the price might not have finished downloading, so we've got to do a check there to make sure that that's right. And then we can do the same thing with the image. The main difference there is we are kicking off an async call to download the images if we don't already have one. Lastly, when we hit the bottom, then we're going to kick off the load of the next 20, and that's going to be a cascading sequence of callbacks that does the whole lot again. All right, so I mean, this is sort of standard iOS view controller code. It's what you'll see in most apps. Just to sort of visualize what's going on here, I spent bloody ages coming up with a keynote animation that shows the controller flow hopping around between the various callbacks that are going on within our view controller. Now, in each of those callbacks, it is accessing the state in some way. It's accessing it or mutating it. And the problem there is, because I haven't finished implementing this. I haven't done purchase authorization. I haven't done restoring purchases. I haven't done managing downloads. I haven't done managing errors. All of these things still need to be done. I'm going to have half a dozen more callbacks and probably some more state. And things are going to start getting very, very fragile. Okay, it's easy for me to look at that state wrong, and then bad stuff happens. So let's say we want to introduce ReactiveCocoa because we think it's going to make things better. Maybe you went along to YOW Connected in Melbourne and watched a very handsome and knowledgeable presenter tell you that you should be doing it that way. So let's see what that might look like as an initial pass. Okay, so what we've done, we've converted our callbacks into signals, but we haven't really fixed anything here. So we're pretty much just converting them back into callbacks using the start with next and then just using callback-based code. And this is really, really common, okay? So if you're dealing with network calls or location updates, it's really, really conceptually easy to map those to signals. But then once you hit the UI, it's sort of not as obvious how you're meant to go about doing things here. And ultimately, people end up just dropping back to callbacks, and they don't really fix anything in that area. So there's not an awful lot of guidance from the ReactiveCocoa community about how you would go about doing that. What is there basically says use a view model, okay? And hopefully some of you have heard of MVVM or seen this diagram before, hopefully because I'm not going to bother explaining it. So I don't like view models for ReactiveCocoa, the reason being that they end up looking like this. Okay, so it's a class, it's a reference type, so it's shared, and then we've got a bunch of mutable properties which are a ReactiveCocoa type that can both consume and emit signals, so they can observe and publish events. Okay, and what ends up happening there is you start seeing things like this, where you've got very, very fine-grained property-based notifications coupling your view model through to your view hierarchy. And then on the other side, we tend to see signals just being wired directly into the view model. Okay, and so in this scenario, you're not really getting the most out of ReactiveCocoa. It's more or less just a glorified bindings layer on the view side. And you've got this sort of stateful object-oriented view model sitting in the middle. It's a bit like the NSA. It's intercepting all of the signals and then passing information on to people on a need-to-know basis. And it's not too dissimilar to the way that we always used Objective-C with KVO. So we can do a little bit better, but how would we do that? So I do like looking at JavaScript view frameworks for that, because ultimately anything that can make sense of a view layer as clunky as the DOM, using a language as awful as JavaScript, must be doing something right. So if we have a look at, I'm slowly pissing off all of the JavaScript developers, aren't I? So if we have a look at React Native, some of the really nice things that are going on there is we've got that concept of the single render method, the props, which have got all of the data needed to render the view, and the one-way data flow. And so we might end up having something like this. So if we can combine all of our asynchronous operations into a single large signal, an Uber signal, if you will, and then just provide a fully formed properties type through to the view controller can just render that within a single callback, and everybody's happy. Okay, and then we can just pass an action up through when we need to perform user interface sort of events, and that can feed back into our signal and re-render everything. So that sounds really awesome, but how do we build this Uber signal? So it's a bit hard to visualize this from the code, so I've done some more breathtaking keynote animations. Firstly, we've got a signal that returns our values from the server. There's only 3 of them, but pretend there's 20 for argument's sake. We can perform a flat map to generate new signals, one of which gets the prices from the App Store, and one of which returns thumbnails from our server. So the prices are good to go. We're happy with those. The thumbnails from the server are an issue because they're coming through one at a time, and because we want to send them through all at once, we're going to have to store them somewhere, which sounds suspiciously like state, and that's a bit evil. So we could do a collect, which will wait till they're all finished downloading and then send through an array, but then we don't get anything until they're all done. So instead we'll do a scan, which basically uses an accumulator like the reduce function in Swift's array, and gradually builds up a dictionary of thumbnails as they come down. Okay, we can then use combine latest, okay, and that will, as I said before, send through a tuple with each of the latest values on each of those 3 signals. Okay, and hopefully you should be able to see from there, we'll be able to do a map from a tuple of arrays to an array of tuples or an array of property objects here. So importantly here, each event that we're sending through is the full list of 20 items, okay, but initially it doesn't have very much detail, and then progressively more and more detail gets added as more information arrives, okay? So we've got a single event which has got all of the information we need to render the view. All right, so let's have a look and see how that might look in code. It's time for coding demo time. You guys aren't as excited about the coding demo as I thought you might be. Yes, coding demo time. Okay, so I have here some properties types which I've generated in Swift. They are immutable Swift value types. Unlike JavaScript, they are actually immutable, as in if you try and mutate them, the compiler will actually give you an error. For JavaScript developers, compiling is kind of like jitting, except it happens before you run the software. So I've got all my values that I need for each row in my comic book row props, and then I've got a top-level store props, which has got the array of rows and an action, which can be used to load more. All right, so let's go back to our view controller code. This is the same you saw on the slide before, and that's not rendering properly. Maybe Xcode needs to be reactive. So I'm going to start with my cell. There's no logic in this cell, which is not uncommon in table view cells at the moment. And what I'm going to do, you guys did not want to watch me type all that out, by the way. So what I'm going to do is declare a props type on my cell, which is a mutable property, and it's of this comic book row props type, which has got the values, all the values I need to render the cell. It's a strongly typed value, so obviously I'm always going to get a value of that type rather than JavaScript, in which case I might get any old rubbish, thanks to the magic of the type system. Sorry, for the JavaScript developers, a type system. Okay, so within my render function, I'm just doing regular UIKit imperative code. Okay, it's an important concept here. I'm not trying to fight the framework. I'm just doing regular UIKit code here. And because I've got all of the information that I need to render that view, I can just do it within that single function. And then within my initialization code, I'm accessing the signal from that property, and then just doing a start with next to start the signal and register the callback, which is my render method. All right, so I've got that working now. Let's do the table view level. So I'll get rid of this horrible manky state. Okay. Oh no, my delete key's not working. That's weird. There we go. So I'll do props at the top level, and I've got a render function. Now, this render function is a little bit more complicated. This is where the React model falls down a little bit. I don't have an automatic diffing framework that's going to work out what's changed, so I can't just re-render the whole table. Actually, I can just re-render the whole table. I could do a table view reload data, but that's not very fun. So what I'm trying to show here is I can do manual diffing by sending through the old and new properties, and then just working out what's changed. And in this case, I'm doing an insert on the additional rows that have been added. So where would I get the old and new properties from? I can hear you asking. I can't hear you asking, I'm just pretending. Okay, so what I can do is use the ReactiveCocoa combine previous, and that's automatically going to send through the previous and the next value, and then I can do my manual diffing and perform my render code from there. Okay, so from now I can get rid of my old callbacks. Okay, and I'm just going to update a couple of bits that are broken. Okay, so this is accessing the mutable property as a property rather than as a signal, which is really, really handy if you're trying to mix reactive and imperative code, and if you're dealing with lots of things that have callbacks. It makes it very, very handy to work with. So what I can do now is I'll get rid of all of my rendering code out of the view controller level, and instead what I'm going to do is bind the props object at the cell level to the props object at the view controller level using this natty little sperm operator. And basically it's going to automatically update. Whenever the properties at the top level change, all of the views, the cells are going to get an updated event on the properties. Now I don't necessarily want that if nothing's changed on that particular row. So I can fix that using what we saw before, which is the skip repeats function. Okay, so now it's only going to re-render the view if something's actually changed on that properties object. Okay, and lastly, I'm just going to do a value.loadMore. So when we hit the bottom of our table view, we're going to kick off a reload, and our signal is going to automatically update things. Okay, so at the top level on the, not that one, sorry, and the app delegate, I can do a similar thing in that I can bind the signal with my properties using the sperm operator again. to my top level signal. So I'm passing in all of the context, all of the state generating component, and I don't need to access singletons from within my view controller, which makes me very happy. All right, so let's run that now. I had to put him on there. Okay, so you can see that everything's loading happily asynchronously, and it's just re-rendering, and then extra things are being inserted when they come down. So that's our demo. Hopefully it shows, I mean, the key elements there are trying to push more of the asynchrony and more of the state into the signal, and then just consolidate what we're working with the view in that single render method we borrowed from React to make it a little bit more predictable and, and easy to understand and work with. Okay, so to wrap up, I'm going to hand back to Ben, and he will go through some other concepts.
All right, thanks, Sam. So there's two things that we've kind of introduced to just get you to start to think about the possibilities that are available to you when it comes to using some functional techniques to write your UI code. Before we wrap up, I think that there's just a few extra things we want to kind of put on your radar if this has piqued your interest. I guess the first thing is, we kind of mentioned this at the start, is that speaking to what React does, really they're just ideas. So they're not specific to the web, as we've proven, but they're not even specific to JavaScript. Okay, so one thing that you might be interested in is something like few.swift. So this really kind of takes some of the ideas behind React and ports them literally to Swift. So here's some few.swift code. Now I'm not a Swift expert, but what you can kind of see there is that they've kind of got a DSL for describing their UI, just as we sort of had with JSX. And it's using a virtual view hierarchy here and taking care of all of that diff process and everything explicitly in this case. And then this opens it up to describing UIs declaratively and modeling change within your application with one-way data flow. That said, few.swift is in kind of at a very early stage. I don't think I'd necessarily describe it as production ready at this point in time. But if you're into Swift, there are other alternatives available. Similarly, there's a component kit if you're into Objective-C. Okay, another thing I want to talk about that you may or may not have heard of in the context of React is Flux. So important thing firstly about Flux is it's just a pattern. I really want to kind of emphasize that up front. It's a pattern that takes this concept of one-way data flow and allows you to apply it to your entire data model rather than just your view layer. So in Flux, we sort of have a view still, and we have a set of stores, and that's where we externalize the state within our application. We have this dispatcher object, and its job is to take actions that are produced by your view in response to some sort of stimulus, send it to that goes to the dispatcher, and the dispatcher's job is to route it to the appropriate store. The store is then responsible for changing the state accordingly, and it gets sent back to the view accordingly. Now, there are a multitude of implementations of the Flux pattern available for JavaScript and also for other languages as well. But if you're interested in bringing this one-way data flow approach to your application whilst still externalizing your model from your view explicitly, the Flux pattern is one way to go. I've seen it used with React Native applications. There's no reason that it can't be used in that context, and I've even seen implementations for Swift as well. Second thing I want to talk about is Redux. Now, this is a bit more of a JavaScript fanboys framework at the moment, but there's, again, no reason that the concepts can't be applied to other languages. Redux is a bit like Flux, but it simplifies elements of it and introduces explicitly the concept of immutability. So in Redux, you still have a view, but you now just have a single store. And that store contains a model, and that contains or represents the entire atomic state of your application at a particular point in time. Just as in Flux, we still have actions that come out of your view, but quite explicitly, Redux has functions that will take an action and a model and produce an entirely new model representing the new state of your application after being transformed by that action. Used in conjunction with something like React, it can then be fed back into the view and rendered efficiently. Again, I've seen Redux being used with React Native quite successfully, and there's no reason it can't be ported to other platforms as well. Finally, there's the big daddy of them all, Elm. So Elm is a compiled JavaScript language that pretty much unifies this concept of functional reactive programming that Sam's talked about with declarative UIs, what I've talked about, and brings them together into one approach. Elm is its own language, and it's typed, unlike JavaScript, and in fact it's got quite a modern type inference engine in it, which is kind of cool. Probably the most notable thing about Elm is that in Elm, like, everything has to be immutable. Mutability is not an option in Elm. Elm also has a concept of signals, just like in ReactiveCocoa, and takes this through to its logical conclusion. So in Elm, you have a signal that represents your model and a signal that represents your view. And the view signal is derived from the model signal. And when actions come into your application, also on signals, they're used to create a whole new model on the model signal, and then that's used to create a new view on the view signal. And so really you're modeling your entire application that way. And even better, this approach composes within your application. So small parts of your screen can use it, and the application overall can use it. And that's kind of what's known as the Elm architecture. And I think what you'll find is that really with things like Redux, everyone's just kind of unwittingly or otherwise gravitating towards the way that Elm does things. So if I've seen React Native being used in very early stages with Elm, but it's certainly not even close to ready for production. But if you're interested in the confluence between functional reactive programming and declarative UIs, I think Elm's a really good place to look at, just to get your head around how the concepts can be unified. So, if Sam and I wanted us to get anything across to you in this presentation, it's just been that there are now alternatives to using traditional MVC approaches to building UIs, be they for mobile or web or anywhere else. And these techniques embrace functional programming paradigms. Okay? Specifically, the sorts of paradigms that help you start to minimize and in some cases even completely eliminate mutable state from your application. And the good news is that you can actually start to use these techniques now. You could use a framework like React Native if you're willing to adopt the all-encompassing approach, or you can start to experiment with FRP frameworks like Sam introduced today with ReactiveCocoa. But either way, whichever way you come at it, I think now's a really good time to start to look at these things and see how they can help you write UI code that's just easier to understand, comprehend, and reason about. Thanks very much.